In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. So in this first problem, this first example, you were given several problems where you were given the Egyptian symbolism for a number and you were asked to put it into the Indo-Arabic numeral, which is what we use. So for this first one here, again, we're going to be using these symbols um, for the Egyptian symbols here. And as we can see from the results of this, we have four of these symbols here, which correspond to 10, and I have 6 of these symbols which correspond to 1. So when I write this out, I'm going to look at it as I'm going to write 4 10s being added together and 4 6s being added together. Now I can also write them as multiplications, and eventually I will start doing that. But I end up getting 40 plus 6, which is 46. And that's the answer for this. Moving on to the next one, we have this symbolism here, and I'll make myself some room here on this. I can see I have 1, 2, 3, 4, 5, 6 of these scrolls. I have 3 of these heel bones, and I have 1, 2, 3, 4, 5, 6, 7, what they call stabs, vertical strokes, whatever you want to call it. So as a result of that, I have 6 times 100 plus 3 times 10 plus 7 times 1, which is 600 plus 30 plus 7, which is 637. On to the next one. Can leave myself some room here. I have 3 of these, what they call as lotus flowers. I have 1, 2, 3, 4, 5 of these scrolls. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 stabs, and I have 1 heel bone. The Egyptian writing, you didn't have to have these in any particular order like some other number systems, including ours, that we do. So when I translate this, I have 3 times 1,000 because each lotus flower is 1,000. 5 times 100 because scrolls are 100. I have 9 stabs plus I have 1 heel bone, which is 10. So adding these together, multiply through, I get 3,519. Then the next one, again, they don't have to come in any particular order either. I mean, according to the, you know, these values here, scrolls are worth less than lotus flowers, but that doesn't have to mean they have to be written in that order. And then sometimes they'll have multiple I's being written because if they have a number that took 2 lines to write, they maybe sometimes try to even out, the symbolism to make it, because it was a very picturesque type system. So, so with this, I have 3 scrolls, each is worth 100. I have 4 lotus flowers, each worth 1,000. 3 stabs on the first line. I have 6 heel bones, which is each worth 10. Then I have 2 more stabs. And so when I total these together, 300 plus 4,000 plus 60 plus 5 gives me 4,365. And then the last one you were given, I have one of these, which is the astonished person, which is 1,000,000. I have these tadpoles, sometimes whales, sometimes known as fish, which are 100,000. These are pointing fingers, which are each worth 10,000. These are, again, these symbols we've already used. So I have 1,000,000. I have 2 100,000 values. I have 5 10,000s. I have 3 1,000s. I have 6 100s. I have 4 10s, and I have 2 1s. Which, of course, causes these numbers to be added together, and when all is said and totaled, I get 1,253,642. And that finishes the first example. In the second example, you're asked to translate the Roman numerals into Indo-Arabic numerals, our form. So again, we have to make use of this and make sure we're aware of the rules of Roman numerals. One of which being that, you can only subtract ones, tens, and hundreds, and only from the previous two symbols. I mean, so I's can be subtracted from V's and X's. X's can be subtracted from L's and C's. C's can be subtracted from D's and M's. So when I look at this first one here, XLVII, I have to pay attention to, like, their values, because if I get, they should go in descending value, which means I should start from the highest value to the lowest. If I get a situation like this one here, I have the symbol for 10 and then the symbol for 50. If that happens, that indicates a subtraction. So these two are put together first, which indicates 50 minus 10. And the rest are in numeric, in decreasing values. So it's 5, 1, and 1. So I'm going to have 40 plus 7, or 47. For the next one, CCCLXXXVI. These are all in descending order. So there's no subtractions going on here. So I have 3 100s, I have a 50, I have 3 10s, 1 5, and a 1, which is 300 plus 50 plus 30 plus 6, which is 386. For the next one, I have DCCLXXIII. Again, they are in order from decreasing value, so it goes from the 500s to the 100s to the 50 to the 10s, and then to the singles. So there's no subtractions going on here. So I'm going to have a 1 500, 3 100s, a 50, 2 10s, and 3 1s, which gives me 500 plus 300 plus 50 plus 20 plus 3, which adds up to 873. MDCCLXXVI. Again, as I go from here, I'm going in descending order. There are none, there are no values that come out of order as far as going from highest to lowest value. So again, there's no subtraction. So I have 1,000 plus 500 plus 2 100s, which is 200, plus a 50, plus 2 10s, which is 20, plus a 5, plus a 1, which is 1,776. And on the last one, I do have a situation here where I have this out of order. I mean, for M, M, and X, it's fine. But the IX at the end, typically it goes in decreasing order. When I have a situation where I have that out of order, that indicates a subtraction. And I am able to subtract a 1 from an X. So I'm going to group them together in these two. This is 2 1,000s plus a 10. This is 10 minus 1, which is 9. So I have 2,000 plus 10 plus 9, which is 2,019. And we got them all right. On to the next example. Now it's the other way around for this one. They're giving us the numbers in our typical Hindu-Arabic number system. We want to convert them into Roman numerals. What I have to be really careful of, the only ones I have to be kind of wary of are any 9s and 4s. I see this one has a 9, this one has a bunch of 9s, this one has a 9. I don't see any 4s here. And the reason because of that is, 9s and 4s are the things that are commonly caused by doing the subtraction with Roman numerals. Any other numbers, I'm just tacking on numbers, the appropriate number of i's, x's, what have you, to come up with the answer. So when I break this down, 89, again, making sure I have my Roman numerals and know what they are. 89, I'm going to consider that to be 80 plus 9. Now, 80 is, just going to be the combination of, well, I could have 150, 250s would be 100 and go to a C, so I would have 150, then I'd have 3 X's to make that, or still get as 50 plus 30. The 9 would be a 10 minus 1, so this would be an L, 3 X's, and then IX to indicate the 10 minus 1. And so this would be LXX IX. And if you'd always want to check it here. Oh, I have too few X's there. There we go. The next one, 236. Now 236, I can think of this as being 200 plus 30 plus 5 plus 1. I'm always looking to see if I can separate out, one of these values in some, or multiples of these values. So I have 2 100s, 3 10s, a 5, and a 1. So I'm going to have 2 C's, 3 X's, a V, and an I. And so that becomes CC XXX VI. For 999, this is where it gets a little bit complicated. I'm going to think of it as 900 plus 90 plus 9. But each one of these, I'm not going to write like 500 and then 4 100s following it. You're only allowed to usually have 3 following that value. Otherwise, you have to kind of knock it up to the next one. So 900 is going to be considered 1,000 minus 100. Hence, you're seeing the 1,000, the C before the 1,000. So what's 1,000 minus 100? The 90 is being considered 100 minus 10, so the 100 with the X before it for 10. And then the 9, you're going to have the 10 minus the 1 before it. So it's CM XC IX. For 1972, I'm going to have a 1,000 plus a 900 plus a 70 plus a 2. The 1,000 is going to be M. The 900, much like it was down here, is going to be CM. The 70 is going to be an X. No, take that back. An L with 2 X's following it, and then you're going to have 2 I's. So MCM LXXII. And then the last one, 2018, I'm going to have 2,000 plus 10 plus 8. So I'm going to have 2 1,000, so 2 M's, an X, and then a V and 3 I's. And there you have it, 100% on that one. On to the next one. In this one here, still Roman numerals, except now we have a situation where we have this bar that's going above the Roman numerals, at least part of it. And that's an indication that I am multiplying this by 1,000. We don't have any Roman numerals that are defined over 1,000, unique values. So they just basically repeat these with bars above them so that you can write them appropriately. So for this, when I look at this first example, I have this long number here. I have this number here. So I'm going to have 1,000 times what's underneath the bar. And what's underneath the bar is essentially 7, V and 2 I's. Then I look at the rest of it. Again, these are all in somewhat, they're in decreasing order until I get to this X here. This X precedes this C. So I'm going to have 500, a 100, a 100, and then plus a 100 minus 10. and then I have a V and an I. So I'm going to have a 500, 200, this is going to be 90, this is going to be 5, this is going to be 1. And so I'm going to add all this up. It's 77,000 plus 700 plus 96, which gives me 7796. The next one, I have all of this underneath the bar. I have this outside of the bar. So this one here, I have two 100s. I have an X before the L, which means I'm going to take 10 away from 50. So that's 245. And this is 600. So 200 plus 45 is going to be multiplied by 1,000 plus 500 plus 100, which gives me 245,600. This one here has quite a bit underneath of the bar here. So all of this, however, is at least in, well, except for the C and the D, these are not in decreasing order. This C is coming before the D, so that means I'm going to be taking 100 away from this 500. So I have 1,000 plus 400. This is 70. The LXX and the V is 5. All that's going to be multiplied by 1,000 because it's underneath the bar. And of course, L and then X is 60. So I have 1,000 times 1,475 plus 60, which adds up to be 147,5060, or 1,475,060. And there we go, 100% on this one. On to the next one. The traditional Chinese symbols. So when you look at the traditional Chinese symbols, I mean, the way they usually do it is if they want to say 600 or something like that, they'll have a symbol, and then it'll be followed by the 100 symbol. So we have to make sure we know of these symbols here. These tens, hundreds, I mean, so basically it's just repeating a lot of these numbers over these numbers. So for instance, this first one here, when I look at what's being translated, going from the chart here, I have a 6, a 10, and a 2. Which basically means since 6 is over the 10, I'm going to have 6 times 10 plus 2, which is 62. For the next one, I have the symbol for 3 over 1,000. I then have a 0. I then have the symbol for 2 over a 10. And then I have the symbol for 9. So I have 3 over 3, then 1,000, 0, 2, 10, and 9, which means I'm going to have 3 times 1,000 plus 2 times 10 plus 9, which is 3,029. For the next one, for C, I have 3. This is the symbol for 1,000. This is 4. This is 100. This is 8. This is 10, and that's 7. So that's 3 times 1,000 plus 4 times 100 plus 8 times 10 plus 7, which ends up being 3,487. For the following one, I have the symbol for 5, then 1,000, then 6, then 100, then 0, then 2. So that's going to give me 5 times 1,000 plus 6 times 100 plus 2, or basically 5,602. And then for the last one, I have the symbol for 7, and then 1,000, then a 0, and then just 8. So 7,000, 0, and 8. That's 7 times 1,000 plus 8, which is 7,008. Which I already have up here. check that off. On to the next one. Now for this next one, we're going to be using the Greek numbers, which is all these listed here. And the Greek numbers are pretty straightforward because all you're doing is adding them up. Now again, there could be some issues from time to time with numbers not necessarily following in the correct order, because they don't necessarily have to with the Greek way either. But all you do is adding the numbers together in some way. Another thing you want to be aware of is this symbol epsilon, which appears to be like the element symbol you saw here. It actually could be looking like a backwards 3. So keep that in mind as well, because depending on the font used, sometimes it shows up looking like a backwards 3, and sometimes it looks like the element symbol that you've seen before in other things. So the first number you were given, and they were rather big in the example, no matter how I tried to fix it, they showed up that big, but I could make them show up as big here, is you had pi, and you had, I forget what the symbol is called, zeta. You had pi zeta. Well, pi does not correspond to 3.14 the way the Greeks did. It corresponds with 80, and zeta was 7. So this is 80 plus 7, which is 87. Here you have tau. I believe that's tau. Yeah, it's tau. Tau? Yeah, tau. You have xi, and you have epsilon. So what you have here is 300 plus 60 plus 5, which is 365. This is chi, this is kappa, and this is gamma. This is like I'm naming some fraternities or something here. So these correspond with 600, 20, and 3 respectively. So I have 600 plus 20 plus 3, which is 623. Here I have Sampi, and I have Kappa, which are two symbols that, in some older Greek does not show up. And then we have Theta. So this corresponds with 900, this corresponds with 90, and theta corresponds with 9. So I have 900 plus 90 plus 9, which is 999. Now we also have, and different books have this mentioned differently, because these will sometimes have apostrophes. Sometimes they're represented with apostrophes that are actually more like commas to indicate numbers, and it really depends on the author, the book, and so forth that's written in Greek. So we're not using any of that symbolism here, but keep that in mind if you would be trying to translate numbers from a Greek text, if you would have a reason to do that. So the other way that we often need to go is, because you notice that the Greek numbers only go up to 900s. So as I start getting to 1,000 or more, I got to start using what they use. One way is this iota that's kind of raised and put prior to the digit that it's being indicated to be multiplied by 1,000. So it isn't this whole number being multiplied by 1,000. It's just the term immediately following it. So if I was doing something like that was a much bigger number. I mean, this is going to be epsilon here is 5, so that's going to be 5,000 something. But I could have 60,000, 100,000. If I wanted to have like a million or something like that, or if I had several things that needed to be multiplied by 1,000, each one would have this iota that precede it. So, if I wanted to have like 36,000, I would have, the lambda with the iota, and then I would have this digamma with the iota as well. But so this is indicating this. I have 5 times 1,000. The 5 coming from the epsilon, the iota, giving the 1,000, 340, and 8. So that's 5,348. For this one here, I'm going to have 1,000 times 6 plus 800 plus 20 plus 1, and get 6,821. On to the next one. Now here we're looking at Babylonian numbers. A couple of things about Babylonian numbers is that, this symbol here usually represents a 1. This symbol here usually represents a 10. This one here is a 1, this one here is a 10. And spaces indicate, kind of like your place value. Now the Babylonian way is it goes by base 60. So, this would be your ones place, which would go, your ones position, or that you're used to, would be like your standard position would go from 1 to 60. So you can have any number represented here from 1 to 60. Actually, 1 to 59. 60 would be over here somewhere. So to get into this one here in particular, the way it's kind of set up, and here's our breakdown here, I have 160 plus a 10 plus a 1, which is going to give me 71. Now this one here, now this symbol here represents the subtraction symbol. So what I have here is this is my standard position. This goes all the way up to about all the way up to 59. This is 60 position here. So according to what I'm seeing here, I'm going to have 160 plus 10 minus 4. So, and that's going to give me a total of 66. For the next one. Now this is all in my 60s area. This is in my units position. So I'm going to have this equates to 10 minus 3. So that's 7. So I'm going to have 60 times 7 plus 3. And 7 times 60 is 420. Adding 3 to that gives me 423. For this next one, again, this is my 60 position, so this is 60. Here I have 10, 20, 30, 40, 50. So I have 5 times 10 plus 4 times 1. So I have 160 plus 50 plus 4, which is 114. This one here, again, this is my 60s position. This is my units position. So I have 10, 20, 30, 40, 50 minus 2. So this is 48. This is 10 minus 1, which is 9. So 50 minus 2 times 60, 10 minus 1. So I'm going to have 48 times 60 plus 9, which is 2,880 plus 9, which is 2,889. Now I have two spaces here. So this is my units position. This is my 60s position. This is my 60 squareds position, or 3600, if you will. So I'm going to have, from this, 160 square. This is 14, so I'm going to have, or 10 plus 4, I'm going to have 14 60s, and this is 44. So 3600 plus 840, because that's what 14 times 60 is, plus 44, gives me 4484. On to the next one of these. Again, I have two gaps, which means that this is my units position. This is my 60s position. This is my 60 squared position. This is 2. This number here is essentially 23. This number here is 45. So over here, I'm going to see 2 times 60 squared plus 20 plus 3, or 23 times 60, plus 45. So I have 7,200 plus 1,380 plus 45, which totals 8,625. And for the last one you were given, Again, this is my units position, this is my 60s position, this is my 60 squared position. So I'm going to have 2 times 60 squared plus 3 times 60 plus 31, which is 7,200 plus 180 plus 31, which is 7,411. And there we have 100% there. On to the next one. So here you're given this number, 9,742, and you're asked to figure out which one of these 4 translations would go in here. So you can click and drag any one of these to this position, whichever one's the right one. So let's translate this and see if we can come up with the right symbolism and then figure out which one of these it is. So coming over here, doing some calculations. Now again, I have to remember that the Babylonian first of all, I have these symbols here to keep in mind. And along with that, I know that the Babylonian system is base 60. So I basically have my units, my 60 position, my 60 squared position, and my 60 cubed position. 60 cubed is 216,000, 60 squared is 3,600, 60 of course is 60, 1 is 1. This number is not anywhere near 216,000, so I know I'm not going to have anything, beyond 60 squared. So kind of makes sense I'm going to have 3 sections here, and each one of these does have 3 sections, so it doesn't limit this. But I just want to make sure I know where I stand with this information. Because one of the things about the Babylonian system is that if I didn't have numbers in the 60 position, I would just have a bigger gap between the numbers. And that sometimes is a little bit problematic because it's like, okay, well, what's a gap and what's a bigger gap? Sometimes it depends on how the person writing it too. So we're not going to get any numbers where that's going to be an issue. So when I look at this, I'm going to go through a division process, which I'm going to use. You're going to see it later when I go into the Mayan system as well. It's going to be very similar to this. What I'm going to do is I'm going to start with the 9,742, and I'm going to divide the 3,600. Now, as I do this, I want to make sure that as I divide, I get a quotient and a remainder. Now, oftentimes, that would require a little bit of time and long division, but I'm going to show you how you can use your calculator to do the same thing. So let me pull up a calculator here. This is the calculator that is in any Windows computer. I believe Mac computers have a calculator on there, or at least there's also apps out there that are free that you can get that simulate a calculator. And I don't do anything with graphing or anything like that. It's just a basic calculator at this point. And most of them do have a setting for scientific. I usually just put on there, but standard would also work too. So I'm going to take the 9,742, and I'm going to divide that by 3,600. Now I get this number right here. So I have 2 and something else following that. So what that means is that I have 2 3,600 or 2 60 squares that come out of this. So I know as I start my division, I'm going to have a 2, and I need to figure out what the remainder is. So what I'm going to do to get the remainder is I'm going to subtract away the 2 from this number, which leaves me with the decimal, which represents what the remainder is. And since I got to here by dividing by 3,600, I'm going to multiply 3,600 to this. And this gives me the remainder I have off of this. So I have 2 and a remainder of 2,542. Now I'm now going to take this number here and divide that by the next tier down, 60. So I'll divide this by 60. And I get 42.3 repeating 6s. It's rounding to the 7 here, but you got to get the idea. So when I get here to the division, I'm going to get 42, and the decimal represents the remainder. So I'm going to subtract away the 42, which gives me this. And I'm going to multiply this by 60, because that's what I'm divided by to get that. And I get 22 as the remainder. And that 22 is going to be, since I'm in the ones position, I would divide, if I divide 22 by 1, I'd get 22. So the 3 numbers I need to have represented in my 3 spaces are 2, 42, and 22. So I'm going to have three groupings of these symbols here to represent these three numbers in their respective positions. So for the 2, I'm going to have just the 2 ones. Now notice that these two over here have the 2 ones. This one and this one has 3 ones. So these two are more or less out. Now for 42, I'm going to use basically 4 of these symbols for 10 and then 2 of these symbols for 1. So that's what 42 looks like. And as you can see, that corresponds with this area right here. Whereas this one, very close, but this one was a little sneaky and put the subtraction symbol in here. So this isn't 42. This is 40 minus 1, or 39. So this symbol here was 39. So that's what we wanted in that position. So we can eliminate this one. And of course, both of these have the same symbol over here because 22 is 2 10s and 2 1s. So it's this one right here that represents the correct answer for 9,742. On to the next question.
For the Mayan system now, in example 9, you're going to take these numbers here, which they're pretty easy to read as far as what the values are. It's just remembering the place values for this. For this one here, you have in the top position, you have 5 and 4, which is 9. So this is 9. And you have 5, 5, and 2, which is going to be 12. So you have 9 in the 20s position and 12 in the 1s position. So when you work this out, you end up with 9 times 20 plus 12, which is 192. Where it gets a little tricky is in the next phase, you have, this is your 1's position, this is your 20's position, and a lot of the temptation is to do 20 squared position, but this is the 18 times 20 position. So we have the number 7 in the 18 times 20 position, we have the number 9 in the 20 position, and we have the number 18 in the 1's position. So when you work that out, you're going to have 7 times the 18 times 20 for this position, 9 times 20 for this position, and of course the 18 for the units, which totals 2718. Back to this now. Again, you have 3 positions here, so this number here is 17. That's going to be in the 18 times 20 position. You have 0 in the 20 position, and you have the number 19 in the 1's position. And so when you total that together, you get 6,139. Oops. In this last one here, you have 3 in the 18 times 20 position, 15 in the 20 position, and 11 in the 1's position. And so that results in having 3 times 18 times 20 plus 15 times 20 plus 11, which is 1,391. Moving to example 10, the reversals, now you're given these numbers down here, and you're asked to slide the right tiles into the right positions. So for the first one, 5207, 5,207 can be broken down into 14 times 18 times 20 plus 8 times 20 plus 7. And so what makes up the Mayan numerals are these numbers right here, 14, the 8, and the 7, so that's what I want to put into those positions. The 14, the 8, and the 7. For 1,316, that can be broken into 3 18 times 20s, 11 20s, and 16 singles. So again, these numbers here are what goes in the respective positions. So the 3 would go in this position, the 11 would go in this position, and the 16 would go in this position. For 6,070, that could be broken into 16 18 times 20s, 15 20s, and 10 units. So again, these numbers being the ones that are going to make up the Mayan numeral here. So the 16, the 15, and the 10. And lastly, the 4,740. That could be broken down to 13 18 times 20s plus 3 20s, and then no singles, no units. So again, these are the numbers I would make use of and put them in their respective places. 13, 3, and 0. And 12 out of 12.
And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.